Okay, so for this example, we're going to use the math library or a file or header file, math.h, to use the function pow. Okay, so we're going to calculate the area of a circle and the circumference of a circle using functions separately, just like the previous example that we did, okay, with the rectangle. So now, here are the formulas. Pi radius square is for your area, and 2 pi radius is for the circumference of a circle. And remember, this time we would like to be able to raise radius to some sort of a power to so the base will be radius and then the exponent will be 2. So we want radius square. To do that, you need the function pow right here that is within the math.h library. So you need to include math.h to be able to use the pow function. Okay. Now let me show you here. Here's the link to the math.h under the C++ reference standard library here. And you can see all the functions available once you have math.h included or linked to your file, to your source file. So in our case, we're looking for pow. So if you slide down here, here's power function, right? And there's different versions of it depending which version of C you're using. I'm just going to go pow in general. And here he is. And it shows you what pow as a function does. So what it does, it's going to expect a double as the base and a double as an exponent, and it will return a double. Okay? And that's how you're going to raise. So basically, if you have a radius of 3, then you put it here. And since the exponent is going to be 2, you're going to put it here. And that will be 3 squared, right? And the 9 will be returned as a float from that function. Okay, that is just the radius portion. All right, so let's go ahead and ask the user to input a radius, and then we'll work from there. So for example, you're going to need float radius at minimum, and maybe result right here. For when you call these functions, you're going to store the result there, right? So one of the things you're going to do is printf, enter, and this is for the input variable, the radius value. Okay, and that would be stored in under radius. So scanf, %f, and %radius. So that's your local radius within main. Now, as I said before, we're going to call some functions. One will get the area, so we're going to have a float get area, and you will supply it with a float, which will be the radius. Notice this is simply a function prototype, how I want the signature to look like. The same thing for the perimeter or the circumference of a circle. So float get circumference, and it will take a float as an argument. So now let's go ahead and define these functions. So let's do the get area. So let me just copy this part here so we're consistent with the naming. And under the function definitions, we will define how these functions work. So notice now I am going to formally say this is my radius here. That's my local radius. And then you're simply going to return. Now, we haven't defined pi, so let's go ahead and do that. We could do it right here, so you could do a const. Or, here, better yet, since we're going to use pi all over the place, why don't we set up pi as a global variable? So const float pi equal 3.14. Okay, so this will be a global variable that we're going to use on both functions. So now pi can be seen everywhere. Okay, so let's go ahead and do this, return. So now we're doing the radius squared times pi. So pi times, and here's how you do it, pow, the function pow, and you supply it with radius and 2, semicolon. That's it. So calling the function pow, notice I didn't have to design it. It already exists in the library file math.h. So all I have to do is use it, right? So notice that it will take a base, and it will take an exponent, right? And it will return, so that means all of this will be a value. Let's say the radius was 3 and we squared it, then this whole highlighted area is actually 9.0. And then we're multiplying that by pi, return it. The same thing with circumference and float. Oh, so let me just copy circumference right here so we're consistent with the naming convention. So let me just copy that, paste it here. And this time again, radius. So formalize it and return 2 times pi, and it can see pi. It's not a local variable. Pi is a global variable. And then this radius that you just passed. All right, close the curly brace. Now, let's go ahead and print the area. So first, you need the result. And let's get the area. So I'm going to call the area. Copy. Equals. And then supply it with the radius that you have here. Printed. Printf, because we're going to reuse the result for the circumference. So we're going to write over it, right? So before you do that, go ahead and print the area before it disappears, right? So area equals %.2f / n, and that would be result. Now recalculate result to get the perimeter. Result equals, or to get the circumference to be precise. Let's copy this. Paste it here. Supply it with result as an argument. And now printf the circumference equals %.2f / n, and basically you print result. Now, could I have called the get circumference within the printf section? Absolutely. Okay, so I'm showing you different flavors on how to solve for this problem. Let's go ahead and compile and run this program. Compile and run. And I didn't save it yet. Let me just copy the name of the file first. So this is arithmetic ex7. Okay. And this would be a .c file. Remember to do that. And then save. And I have a printf error right there because I had an E where it's supposed not to be in there. There you go. And we have enter radius. All right, so let's enter a radius of 1.1. And there you have it. The area is 3.80, and the circumference is 23.86.